Okay, so we're going to graph our function. We're going to walk through all of our steps. So remember that we want to find out if there are any holes, vertical asymptotes, horizontal asymptotes, and or slant asymptotes. So the first thing we want to do is look at our function and see if there's anything in common between the numerator and denominator. Are there any factors? There's nothing in common, so we do not have any holes. Vertical asymptote, it's going to be x is equal to -2, because if you set our denominator equal to 0 and solve, that's what we're going to get. Horizontal asymptote, so our highest degree in the numerator is a 0, highest degree in the denominator is a 1. So 0 is larger, or sorry, 0 is smaller than 1. So that means that we are using our y is equal to 0 because it does not have a slant asymptote, because it has a horizontal asymptote. So there's our basic idea, right? If I was to just quickly graph this, here's at -2, so I would have, right, your vertical asymptote here. We have a vertical asymptote, or sorry, horizontal asymptote right there. Then we want to find some points. So let's find our x-intercept. So x-intercept means that we would set our equation equal to 0. And if I do that, I'm going to get 0 is equal to 1. So that means that we're not going to have any. We also knew there was not going to be a horizontal asymptote, x-intercept, because that there is a horizontal asymptote. Y-intercept. Right, what you're doing is you are plugging in a 0 everywhere we see an x, so 1 over 1 plus 2. So that means our y-intercept is 1/2, right? So that means over here that if this is 1, we have a point right there. So what does that tell us? Our graph kind of looks like it's heading off in this direction. And we probably want to plug in some numbers to figure out that we're down here. So let's plug in -3, see what happens. So 1 over -3 plus 2. So this will give you a 1 over -1, which gives you -1. So let's pretend -1's right there, -3's right there. So there's our point. So our graph is looking like this. Obviously, the more points you put, the better your graph is going to be. Let's see what it looks like on Desmos. So here is our equation. Zoom in a little bit more, so we can see right there 0 and 0.5. It's not crossing your x-axis. Here is your vertical asymptote. Here is your horizontal asymptote, and we said the point -3, -1. It's right there. And again, any point we could have plugged in. -4. Right, would have got -0.5. If I plugged in a 2 over here, right, we would have gotten 0.25. So again, other numbers that we can plug in. All right, let's go to the next problem. So the next one was number 15. So again, let's focus on holes, vertical asymptotes, horizontal asymptotes, slant asymptotes. So first thing I'm going to do on this is factor. So this will just be x times x. So I'm going to leave this as x squared for just a moment. This will be x plus 2 and x minus 2. There's nothing in common between the numerator and denominator, so we don't have any holes. We actually have 2 vertical asymptotes on this problem. Okay, and I meant to show you guys an example about this in class, which is perfectly fine. But we ran out of time, so I apologize for that. But we'll talk about it through this problem. So we have 2 vertical asymptotes, -2, +2. Horizontal asymptotes, so again, power of 2, power of 2. So 2 is equal to 2, so we're going to take our coefficients and divide them from each other, which means our horizontal asymptote is y is equal to 1. We do not have a slant asymptote. So what's happening right now is our graph kind of looks something like this. So here is -2, +2 I should say. Bam, -2. Right. Here's +1. Okay, and there's our two graphs. Please make a note. Okay, you will never, so graphs will never cross vertical asymptotes, ever. Right? That's huge. You're never going to be able to plug it in because it's automatically going to give us 0 in a denominator. Okay? The second thing I want you to write down is that your graph, so the graph may cross a horizontal asymptote unless it is going to infinity or negative infinity. So that means, so basically what this means is my graph on this side of the graph, so it's either up here or down here, will never cross this horizontal asymptote because the horizontal asymptote is going on forever and ever. So it's going on to positive infinity. Over here, again, if the graph's up here, the graph's down here, it's going to get close to your asymptote, but it's never going to cross it. Between x is equal to -2 and x is equal to +2. So from here to here, my horizontal asymptote is not going to infinity or negative infinity, which means that you may cross it. There are two basic graphs for right now that your graph's going to look like. It's either going to kind of look like a parabola, either opening up or down, right? Either up or down, or it's going to kind of look like a cubic, so look like that or like that. Those are kind of the forward-looking graphs. They may look like something else, but those are the main ones that we're going to look at. So it will follow your asymptotes. So do not be surprised. So my suggestion to you is this: plug in numbers between your vertical asymptotes. All right, so the next thing I want to do is find x-intercepts. So let's set, so x-intercepts. And so basically your 0 is equal to x squared minus 4, cross multiply, so 0 is equal to x squared, x is equal to 0. So that means 0, 0 is our x-intercept. So let's plot a point right here. So we're underneath our graph. Lovely. Let's find a y-intercept. So this will be f of 0. So 0 over 0 minus 4. Who cares what that is? So that is going to be 0, 0. Lovely. So we have our points. Those points don't help us with anything, so now we got to plug in some more points. So let's do that. So let's plug in f of 1. So 1 squared is 1, 1 minus 4, so 1 over -3. So 1 over -3 is somewhere probably down here. So we'll just say it's right there. So let's plug in -1. So let's see what happens at -1. So -1 squared is still 1 minus 4. Excellent. So like I said, this one's a parabola-looking shaped graph. So our graph again is going to start here, come up, and then go right back down. So that's lovely. Okay. So it's not crossing your horizontal asymptote. We do need to figure out: are we up here? Are we up here? Are we down here? Are we down here? So let's plug in some more numbers. So let's plug in f of 3. So 3 squared is 9. And then 9 minus 4, so this will be 9 over 5. So 9 over 5, right, would be on this side of your graph. So we're probably looking at our graph like that. And then again, if I plug in a -3 right here, everything still stays the same. So again, my graph is going to look something like that. Okay, so that's what my graph looks like for number 15. Again, let's check it on Desmos really fast. So Desmos, here we go. So here are those numbers. So we're up here and we're up here, right? We said if we plugged in -3, so here's -3 and it's 1.8. Again, +3 is going to be, right, 1 point, past 3, sorry. And there it is, 1.8. And there's our other points. Okay, let's do one more on this video. So let's do 17. So again, let's do holes, vertical asymptotes. Let's do slant, not slant first, sorry. Horizontal asymptotes, slant asymptotes, x-intercepts down there, y-intercepts. Okay, so again, x over x plus 1, x minus 1. There's nothing in common between the numerator and denominator, so we don't have any holes. Asymptotes are at -1 and +1. This time, notice that there is it's 1 on the top and 2 on the bottom, so we should be at y is equal to 0. We do not have slant asymptote. Okay, so horizontal asymptote at y is equal to 0. Set our equation equal to 0. We're going to get 0 is equal to x. So notice that we have an x-intercept at 0, which is interesting. Notice that you have a horizontal asymptote at y is equal to 0. So this is what I was talking about, how our graph can cross your horizontal asymptote. So I'll show you in a second. Plug it in. This will be exactly the same thing. So again, we have a y-intercept at those points. So if I make a little makeshift graph, so here's -1 and +1. And let's draw it in blue this time. Alright. So x is equal to -1, x is equal to +1, and at our, right, this is your y is equal to 0 phase. So we do have a point, and it's on our horizontal asymptote because between here and here it is not going to positive or negative infinity, so it can cross. So we want to see kind of what's happening. We can plug in some other numbers. So let's go ahead and do that. Let's plug in 2 first and see what's happening over here. So 2 over 4 minus 1, so that will be 2 over 3. So that will be up on this side. If I plug in -2, this will be -2 over 4 minus 1, which gives you -3. So we're down, looks like we're down here, -2. Let's plug in some more numbers. Let's plug in a half, see what happens. So I have 1/2 all over 1/4 minus 1, which gives you 1/2 divided by -3/4, which is the same thing as saying 4 over -3. So we are going to get, what are we going to get? We're going to get -2/3. So -2/3 is down here. So notice that we are crossing it. If I plug in a -1/2, notice that that becomes negative, that becomes negative, which means this becomes positive. So you'll be +2/3. So what's happening with our graph is this time this graph is going to look a little cubic through here. Whoop. And then this graph should be focusing on these asymptotes. So it is getting, as x is approaching positive infinity, right? So as x is approaching positive infinity, right, your output is approaching 0. Okay, that's what the end behavior looks like over here. And then over here, again, what we can say is that x is approaching negative infinity. Your f of x is approaching 0 on that side. Over here, our x is not going to negative infinity or positive infinity, which means I can cross my graph, or my asymptote. So let's see what that looks like. And here's our graph. So notice that we do have that point. So notice that it is crossing, and it does look a little cubic.